Alright, so let's talk about this idea, mutually exclusive. This is when two sets have nothing in common. Alright, so let's say that we have a new set, we'll call it A, and this says, let's say it's just the number 5s, okay? And let's say B is the number 2s, like that, okay? So notice that if we pick these out, A is made up of 5, 5, 5, and 5. Okay, so all of those are the A set, and our B set is 2, 2, 2, and 2. Okay, so notice that they have nothing in common. There's no 2s that are 5s. So we would say that these two sets are mutually exclusive. A and B are mutually exclusive. Okay, so another way would be if it's the probability of A and B is 0. Okay, so anything that's impossible, the probability of an impossible event is 0. Okay, the probability of an impossible event is 0. The probability of a certainty is 1. Okay, now I've been saying these things all along, but also recall that anytime we're talking about probabilities, any probability of any set has to be between 0 and 1. That always is the case. And we can write probabilities also as percentages. So another way to say this would be to say that it's between 0 and 100%, because 1 is equal to 100%. Okay? Right, so we're going to do some problems with mutually exclusive and not. So let's look at this. If two sets like A and B are mutually exclusive, right? Now I want to know how many are in both. Notice they have nothing in common. So when I count them, I have all of A and all of B and nothing in common. So really this is the number of things in A plus the number of things in B all over the number of things in both, the sample space. So this would become the probability of A plus the probability of B. Now, if it's two things that have something in common, like say E1 or E2, notice that they have something in common. I could still count the number of things in E1 plus the number of things in E2, but what I've done is I've counted these things twice. So if I count them twice, I have to get rid of one of them and only count once. So I'm going to subtract out the number of things that are in both of them, which was this set here. And again, all over the things in the sample space. So the formula becomes the probability of E1, probability of E2, minus the probability of E1 and E2. Alright, so if we just throw some numbers in this, the probability of A or B would be 4 out of 16 plus 4 out of 16 is 8 out of 16, which is 1/2. The probability of E1 or E2 would be the probability of E1, well there's 4 out of 16 in that one, plus 2, 4, 6, 8 out of 16 in that one, minus the 2 that they have in common. So I get 10 out of 16, or 5/8, like that. Alright, mutually, so these two were mutually exclusive, and these are